In this video, we are going to show you what the AlbaCombi is. Basically, the AlbaCombi is an analog to NMEA 2000 certification pending converter. What it does is, on a small package of 6 DIN rail size, it has got a analog to digital converter, and it has got many inputs and a couple of outputs to be able to do basically all your monitoring from analog sensors and display that you can do on a medium-sized small boat. Now, this unit that you can see here is basically the AlbaCombi. It's rather small, self-contained, and everything is in there. So no calibration tools, no external interfaces, nothing. That's everything. Everything that you need is self-contained on that box. So what it does, basically, the first thing that the unit is different from other units that we had before and other units in the market is that it has got an Ethernet connection. That connection basically has three purposes, basically two, if I can summarize it that way. One of the reasons Ethernet is there is to avoid you the hassle of calibration. Now, other solutions have got a rather complicated interface solution or their own dedicated display or things like that. But with the AlbaCombi, you just have to have a laptop, Ethernet cable, and that's about it. So you connect your laptop to the Ethernet input, open your browser, connect to the IP address of the AlbaCombi, and then you are presented with a web page in which all the calibration is done. Secondly, if for whatever reason you have to update the unit, on our web page you can download the new software and you can update your AlbaCombi through that Ethernet connection. Now, and the third thing, and very important indeed, is that the AlbaCombi has got inside a monitoring software in which you can monitor and display all your analog inputs that you are using, being from just one tank or a couple of tanks to a full boat with engine, tanks, batteries, etc. Now, the unit basically has got, of course, beside the Ethernet connection that I've just spoke about, the unit has got a 1, 2, 3, 4, 5 connections to CAN. Basically, it can connect to any sort of CAN, but it's programmed to be compatible with NMEA 2000. As I mentioned before, the registration is pending, but we're working on it. But as far as the software is concerned, it's fully compatible with NMEA 2000. So the unit, you can use any cable, any either standard NMEA 2000 cable or Raymarine cable or Simrad cable or Garmin cable or Lowrance cable to connect directly to those 5 connections. Those connections are supply, positive and negative, shield, CAN high and CAN low. That's standard for many NMEA 2000 connection. Now, if you just happen to use the AlbaCombi just as a monitoring, its own monitoring solution with the computer connected to the Ethernet output, no NMEA 2000, you just need to supply through those two CAN supplied. Obviously, being CAN is always 12 volts. The supply, the unit consumption is 150 milliamps, so it's 3 lane. It's not that much because the unit is a embedded unit, very low power. in terms of consumption, high power in terms of performance, low power in terms of consumption, it can be connected directly to the CAN bus and supplied from there, or it can be supplied by its own power supply. Now, one of the important things that this unit has is that this supply, both CAN and supply, is galvanically isolated as NEMIA 2000 mandates, and that means that any grounding that you do on the analog connections will not affect the supply. So ground of the supply can be different, or may be different from ground, should be different from ground of the well, maybe sometimes it may be the same ground, but the fact of the matter is that the unit has isolation in both supply and CAN. Now, so you've got your supply and your NEMIA 2000 connection, and you've got your laptop connected to Ethernet. Either I mean, when I mention laptop, it can be laptop or iPad with Wi-Fi or something, anything which is Ethernet and has got a browser. Now, besides that, you've got your inputs. Now, the first thing that you've got is ground, and one very important thing is that all the grounds on this unit are common. So any connection or connections that you do have to have common ground. If you happen to have inputs that have different ground, they have to have different boxes linked through the CAN bus. So this unit assumes or has internally all the grounds connected. So the first thing that this unit has is two RPM inputs. Those RPMs can come from two engines, from the W output of the alternator, or from a sender connected to the engine, or whatever. It has got a sine wave coming from the engine, from the alternator. Most of the times will come from the alternator, from the W signal from the alternator, or directly in parallel with the input of the RPM indicator that you've got already on the bolts. So provided that the ground is common, you can monitor up to two engines in there. Now I will skip the outputs, and then the second thing that we've got is the PTC 1000 with its ground. This ground is a little bit different because this ground is there for the PTC 1000. Now the reason why we've got a PTC 1000 is because this is a high precision temperature. If you happen to need a high precision temperature, you can use a standard PTC 1000 thermistor. Now the third thing are the RS232 TX and RX. Normally those two inputs are not needed. The only reason why you may need those two connections is because if the unit in programming gets wrongly programmed, you can always reflash this unit through RS232, regardless of what has happened through the Ethernet programming. Now the CAN connection and supply and shield that we have spoken before, and then on the other side we've got the very interesting inputs. Now I've got ground and then 3 voltage or resistive inputs. I will talk about that later, but those inputs can be either a voltage from 0 to 32 volts, and you've got 3 inputs, or those inputs can be resistive from 0 to 5K, 5000 ohms. Now you can program individually any of those inputs to be, as I mentioned before, either resistive or voltage, and you can do with any of those inputs, you can assign to anything internally. Either you can sense voltage from a battery, you can sense level from a sender, you can sense temperature from a sensor coming from the engine, temperature from a sensor coming from live well, you can sense pressure coming from oil from an engine, oil pressure. So you can sense a variety of things, or either say, imagine that you've got 3 batteries, you can sense the voltage of every battery and feed that to the NEMEA 2000, or see that voltage information in the display in the built-in monitoring web page. Now, so you've got 3 voltage or resistive inputs, ground for all those 3, another ground, another 3 either voltage or resistive inputs. Just as I mentioned before, those 2 grounds are exactly the same. The only reason why they are done the way they are done is because since there are a certain limit on the number of screw connections, we had to put strategically the grounds every 3 connections. But as I mentioned before, all the grounds are common and should be common. So for instance, with that, imagine that you've got 2 engines with 2 senders, 2 temperature and pressure senders each. That's 4 senders, and you've got 2 tanks. That's 4 resistive, 2 every engine, 4 plus 2 tanks. You've got 6 senders in total, so resistive senders. So you can use all those 6 inputs, and then you will be able to monitor 2 pressure, 2 temperatures coming from 2 engines. One temperature, one temperature and pressure from one engine, another temperature and another pressure from the other engine, and 2 tanks, all with those 6 resistive inputs. And then we've got shunt. We only have 1 shunt, so it means that normally with this we will measure service battery current. We can use any shunt, can be calibrated for any current. Now, and then we've got 1, 2, 3, 4, 5, 6 voltage input. Now, imagine that you've got a boat with 2 engines and 1 service bank. So you will use for that 1 input, one battery for 1 engine, another input from another battery from the other engine, and the 3rd input from the service bank. Aside of that, so we have in the example that I'm just going through, which is 2 engines, 2 tanks, 3 batteries, we have used almost 9 inputs, but we still have 3 left for voltage. Now, if you happen to have more inputs or more batteries or wherever, you can use those. Now, obviously the unit has got an intricate calibration. I will talk about that on a separate video. But basically, any input can be calibrated to any range of any calibration curve, and can be assigned to any PGN, and can be assigned to any gauge that will be displayed on the monitoring page. Now, talking about inputs, all the voltage input are the resistive inputs can be used from 0 to 4000 ohms, or voltage from 0 to 32. The voltage is one or the other. The voltage input can be used for 0 to 32 only. Now, the RPMs can be used with W signal from an alternator or magnetic sensor from the engine, from the crankshaft, or whatever. We've got 1 precision temperature coming from a PTC 1000, and we've got 100 millivolt current shunt, but basically can be configured to any input any type of tune that we want. Now, the unit is highly precise. Normally, the precision of the unit is much better than 1%. And most of the times, if not always, the precision of the unit will be much better than the sensor itself. Now, I've spoken about the open collector outputs in here. Now, we've got two open collector outputs, which basically will drive a relay or any other thing with the ground open collector running here. So you can configure internally in the unit alarms. In those alarms, you can configure alarms for any input, and you can drive with those alarms those two relay outputs. So it means that if a tank goes below a certain level, or a temperature goes above a certain level, you can drive those relays with the internally set alarm. Now, as I mentioned before, all the calibration is done through Ethernet. The monitoring is done through Ethernet. The reprogramming is done through Ethernet. So everything can be done through Ethernet. Now, Ethernet can be used only in calibration, or can be used, and that will be a technician sort of usage. You set up the unit, you let it working, you check that the value that the unit is giving are correct, you unplug the computer, and that's it. If you happen to need it after that, the Ethernet connection will always be there, so you will never need a separate calibration tool or something. In your boat, you always will have the calibration method, or the way to calibrate the unit. Now, as I mentioned before, the unit has got an RS-232. It's only to recovery. The unit has got what we call bootloader and software. If you happen to, for whatever reason, the bootloader gets corrupted, you'll always be able to recover the unit through the RS-232 connection. Obviously, the unit has got the NEMEA 2000, as I mentioned before, pending certification, can interface isolated as it should be. Voltage is standard NEMEA 2000 connection. Consumption is 150 milliamp, 3 len. Size is standard DIN size, size 6. And PGNs that you can use are engine, rapid update and dynamic, battery status, fluid level, temperature, and actual pressure. You can fill those engines with the information coming from these sensors. And actually, as well, if you set any alarm, you can fill up the binary switch bank status with the value of the alarm. Okay, so I will close this datasheet we have just explained, and I will open the photo of the unit internally. Now, if you see on this side, you've got 6 switches. Now, the right hand side switch is number 1, and then 2, 3, 4, 5, 6. Those 6 switches define whether the channel connected to it, which will be 1, 2, 3, 4, 5, 6, are configured in voltage mode or resistive mode. In this case, as you see in this indication on the PCB, all the channels are configured as resistive. Now, if any of the channels, say channel number 1, this switch is on the up side, like in here, this particular channel is in voltage. So say that this particular channel, the switch is in the up side, like this. The channel 1, which is this channel in here, this channel in here will be configured as voltage mode. Now, to configure that, of course, you will need to open the unit. It's done through with a screwdriver. It's very easy to do. Now, once you have the unit set up and connected, you don't need to check this, because when you go into the browser and you try to configure the unit, it's very easy to see, because when you access to one channel, it will tell you what is the configuration of that particular channel. So once it's configured, you don't need to check it out again. So every time you go to the browser, you will see it. Now that same thing applies for channels 1 to 6, and again, if you go in here, that applies for channels 1 to 6. Now, if you noticed, there are a couple of things more on the PCB. One is this button. This is a reset button. You don't normally need this, but there is this reset button, which is basically the same as switching off and on the unit to power cycle. Now you see here that there are two small switches. Those two switches normally have to be on the off position, that is in here. So in the looking from this perspective, in the up position. Switch number 1, what it does, when you put it into the on position, it will open a different page when you go with the browser, and that page will allow you both to check all the inputs at the same time and see what voltage or what frequency or what resistance is coming to that input. So in that way you will have a quick snapshot of what is connected to the converter in all the inputs at the same time, and as well will allow you to see the serial number of the unit, the software version of the unit, and will allow you to reflash the unit, to reprogram the unit. Now, when we supply software, we supply two things. We supply bootloader and software. Normally the bootloader does not need to be changed unless something very specific has to be done. So this switch number 1, when it is on the on position, is used. So you, to go into upgrade mode, you move switch number 1 to the on position, press reset, refresh your browser, and you will get the calibration and reprogramming page. So it's only needed on that on that reprogramming or check, and once that is done, you put again your switch in the off position, reset again, and the unit will behave as the standard unit. Now, switch number 2 is very specific. It's only used when, for whatever reason, the software of the unit is corrupted, or you load a wrong bootloader or something, and then with special software that we supply, you can reflash the unit through the RS-232 port. Now, the processor in here has got a ROM bootloader which works through RS-232, which means that anything that we do into the unit will always be recoverable through RS-232. It will take longer, but it will be recoverable. Now, aside all of that, the only thing worth mention, it is this thing in here, which is a fuse. The unit is polarity protected, supply-wise, but if for whatever reason it happens to have anything in the connection or in the power supply or whatever, the fuse will blow. Now, you've got a small LED in here which will show you that the unit is receiving and transmitting, and from NIMIA 2000. As well, you've got your typical LEDs in here. So in here you've got your link LED to tell you that you have established a link with your laptop Ethernet wise, and your transmission and reception LED, which means that the unit is transmitting and receiving. Nothing else. You've on the unit, one thing that we took a lot of care is that even if you don't have the instruction manual, on the unit itself, all the connection numbers and the meaning of every connections are marked. So if you go to a boat, you don't have the instruction manuals, and if you check on the front of the unit, you will be able to understand what input is used for what purpose. So it means that all in all, this unit seems to have a lot of things, and indeed it has, but you don't need to use all of those. So imagine that you only want to monitor a couple of tanks. You can use this unit for that. Or you want to monitor one battery, or a couple of batteries, you can use the unit for that. Or you want to monitor 2 engines, you can do that. So you can do any combination of things that you want, providing that the ground is common. This is very important. Ground always have to be common. If there are floating grounds or different grounds, then you've got to either make them common or use 2 units instead of 1. Now I will finish here, and on a second video I will start to show you step by step what is the calibration process and how this is achieved.